Welcome back to the Revit Modular Training Series. In this module, we're diving into one of the most practical and hands-on aspects of M.E.P modeling: equipment, fixtures, and fittings. We'll explore how Revit handles both freestanding components like pumps, boilers, and tanks, as well as hosted elements such as vents, sockets, and switches. You'll learn how to select components, position them accurately, rotate and orient them, and manage their behavior inside the model. This module also ties directly into the model development methodology. Early in a project, we often place Grade 0 schematic or Grade 1 conceptual components, simple placeholders that represent the category. Later, these are replaced with detailed manufacturer-based families rich in metadata. Understanding this workflow is essential for efficient modeling and clean project development. Along the way, you'll also reinforce your skills with basic editing tools: move, copy, align, paste, and see how they apply to real M.E.P components. By the end of this module, you'll be able to understand key component and family terminology, place both hosted and non-hosted elements correctly, manipulate, edit, and replace components efficiently, use essential editing tools such as move, copy, align, and paste. These skills form the backbone of equipment placement in Revit. Family terminology. In Revit, the word family is used everywhere, but it doesn't always mean the same thing. There are four main types: view families, used to interrogate model data system families; walls, floors, ceilings, and logic-driven elements; standard, loadable families, the 2D and 3D components we load into projects in-place families; custom objects built directly inside a project. In everyday practice, when people say family, they usually mean standard families, the loadable components like valves, fixtures, terminals, and equipment. A strong, well-maintained family library is critical. Poorly built or downloaded components can slow down projects, break schedules, and introduce bad modeling habits. Always test new content thoroughly before adding it to a corporate library. Model versus annotation families. Families fall into two broad categories: model families, physical components like ducts, cable trays, walls, and equipment; annotation families, dimensions, tags, symbols, and text. It's not simply a 3D versus 2D distinction. Model families represent real objects. Annotation families describe or label those objects. Component placement. Components can be hosted, placed on walls, ceilings, floors, roofs, or faces. Level hosted. Freestanding elements placed on a level. Work plane based, placed on any defined plane. Even freestanding components can sometimes detect nearby hosts. For example, a toilet placed on a level may automatically adopt the offset of a floor slab if that slab existed before placement. But this behavior does not apply to all categories. Hosted elements like doors behave differently. Family templates and hosting. When creating a family, the chosen template determines its host. For example, a wall-based template produces a wall-hosted component. A ceiling-based template produces a ceiling-hosted component. A generic model template produces a freestanding component. Once a family is created, its hosting behavior is permanent. A wall-hosted element must be placed on a wall, will be deleted if the host wall is deleted, cannot be hosted by a linked model, can only be swapped with another wall-hosted family of the same category. Groups can be used to swap mixed categories, but individual hosted elements cannot. Placement behavior. When placing hosted components like doors or switches, the face under your cursor determines orientation. Pressing the spacebar flips the component during placement. After placement, flip arrows allow you to change direction. If you copy, mirror, or array a system family that contains hosted elements, such as a wall with switches, the hosted elements are duplicated along with the host. Openings, cuts, and voids. Hosted families can cut openings in their hosts. There are two methods. Opening cuts always cut the full thickness of the host. Void forms, more flexible, but cannot coexist with opening cuts in the same family. Void forms are not recognized by copy/monitor, which can lead to coordination issues. For this reason, best practice is to use copy/monitor only for levels and grids, reference planes, and swapping components. Inside a family, reference planes define the left, right, top, bottom, and center of the object. When you swap one family for another, Revit aligns the new component to these reference planes. If a dimension references a standard reference plane, it will remain intact after swapping. If it references a custom reference plane, the dimension may be deleted. Line-based families, most components are placed with a single click. Line-based families, however, require a start and end point. These are useful for linear objects like trench heaters, cable trays, or custom duct accessories that need to stretch parametrically. Levels and placement strategy. System families like walls and stairs have both a base and top level. Custom families generally have a single base level with a height or offset. When placing M.E.P equipment in ceilings, teams often debate how many levels to create. Some use only FFL levels, others create bundles of levels, FFL, SSL, floor soffit, ceiling plenum. Using a dedicated ceiling plenum level can make M.E.P coordination easier, especially when ceilings move. However, contractors may prefer measurements from the actual ceiling, not a theoretical level. The key is early agreement within the project team. Visibility control. Sometimes, after placing a component, Revit warns that the element is not visible. This usually happens because the element is above or below the view range. The view discipline hides that category. Visibility/graphics overrides are turned off for that category. Using VG or VV allows you to toggle categories like electrical fixtures, mechanical equipment, or plumbing fixtures back on. Multi-story design and the clipboard. Many components need to be repeated across multiple floors. Revit's clipboard tools allow you to copy elements, paste them aligned to selected levels, duplicate them across multiple stories at once. This is extremely useful for repeating equipment layouts, riser components, or standardized room configurations. This concludes the main content for Module 8, Equipment, Fixtures, and Fittings. You now understand how Revit handles families, hosting, placement behavior, visibility, and multi-story duplication, all essential skills for accurate and efficient M.E.P modeling. Let's move into the practical exercise where we place equipment, fixtures, and fittings directly into the model. In this exercise, we're going to put everything we've learned into practice by placing equipment, fixtures, and fittings inside a Revit model. Please don't forget to like and subscribe. We'll work with both freestanding level hosted elements and system hosted components, and we'll also explore visibility controls and multi-story duplication. The exercise begins with the model WFPRME08 Equipment A as shown. Let's get started. Part 1. Level hosted, freestanding elements. These first components are level hosted, meaning they're not attached to walls, ceilings, or floors. They simply sit on a level and can be placed in plan or 3D views. Step 1. Open the ground floor plan and section 1. From the project browser, open the ground floor plan and also open section 1. Step 2. Tile the views. Tile the views so both the plan and the section are visible side by side. Close the splash screen if it's still open and tile again. Step 3. Make the floor plan active. Click inside the ground floor plan to make it the active view. Step 4. Select the mechanical equipment tool. Go to the Systems tab, choose Mechanical Equipment, and from the Type selector, pick the 7,570 liter storage tank. Step 5. Place the first tank. Move your cursor into an open area of the room. Press the spacebar to rotate the tank in 90-degree increments, then click to place it. Step 6. Cancel the command. Press Escape twice or click Modify to cancel the placement tool. Step 7. Locate the tank in the project browser. In the project browser, expand Families. Then select Mechanical Equipment, then select Storage Tank and highlight the 7,570 liter type. Step 8. Drag and drop to place a second tank. Drag the 7,570-liter tank from the browser directly into the plan to place a second tank on the lower section of the floor. Step 9. Create instance. Right-click the 7,570-liter tank in the browser and choose Create Instance. Step 10. Place the third tank near the diagonal wall. Move your cursor over the diagonal wall and press the spacebar repeatedly. Notice how the wall influences the rotation of the tank. Move slightly away from the wall and place the third tank parallel to it. Step 11. Cancel the command. Press Escape twice to cancel. Step 12. Rotate all tanks. Select all 3 tanks and press the spacebar. Each tank rotates around its own insertion point. Part 2. Air terminals and level offsets. Step 13. Place an air terminal. From the Systems tab, choose Air Terminal and select any available type. Place one in the ground floor plan. Step 14. Cancel the command, press Escape twice. Step 15. Adjust the terminal height in section 1, select the air terminal. In the Properties palette, set the offset to 2,500 millimeters. Step 16. Open the Plenum 1 plan. Open the Plenum 1 floor plan and select the air terminal. Step 17. Use the Copy tool. Click Copy from the Modify panel. Step 18. Copy the terminal 3,000 millimeters horizontally. Click a start point anywhere, move horizontally, type 3,000, and press Enter. This creates a listening dimension and places the copied terminal exactly 3,000 millimeters away. Step 19. Place a third terminal. Use the Air Terminal tool again and place a third terminal in the Plenum 1 plan. This one will have an offset of 0 because it's hosted by the Plenum level. Step 20. Place a fan coil unit. Select mechanical equipment and choose the 658 LPS fan coil unit. Ensure the level is set to Plenum 1 and the offset is 600 millimeters. Place the unit using the spacebar to control orientation. Part 3. Using ceiling plans for accurate placement. Step 22. Open the ground floor ceiling plan. Open the ground floor ceiling plan. A temporary ceiling has been added 300 millimeters below the real ceiling to help align components. Step 23. Place an air terminal on the ceiling grid. Select air terminal again. Ensure the offset is 0 from plenum 1. Place the terminal so its center aligns with the green ceiling grid intersection. Step 24. Move other terminals to the grid. Select the previously placed terminals and move them onto the green grid intersections. Part 4. System-hosted elements. Step 26. Return to the ground floor plan. Go back to the ground floor plan. Step 27. Select Plumbing Fixture tool. From the Systems tab, choose Plumbing Fixture. Turn tag on placement off. Step 28. Place a wall-mounted water closet. Place a default wall-mounted WC on the diagonal internal wall. Step 29. Cancel the command. Step 30. Copy the WC 2000 millimeters along the wall. Select the water closet, choose copy, and move it 2000 millimeters along the wall. Because it's wall hosted, it can only move along the wall. Step 31. Right-click the WC to open the context menu. Step 32. Choose Create, Similar. Select Create Similar to activate the Plumbing Fixture tool with the same type. Step 33. Place another WC. Place a WC on the straight section of the internal wall. Step 34. Cancel the command. Part 5. Visibility Control. Step 35. Place an electrical fixture. From the Systems tab, choose Electrical Fixture and place a socket on any internal wall. Step 36. Cancel the command. Step 37. If the fixture is not visible. If the socket disappears, it's due to visibility settings. Step 38. Open Visibility/Graphics. Type VV to open Visibility/Graphics. Tick electrical fixtures. Step 39. Confirm visibility. Click OK. The socket should now be visible. Part 6. Multi-story design using the clipboard. Step 40. Select the 3 storage tanks. Select all 3 storage tanks and copy them using Ctrl+C or the copy icon. Step 41. Expand the paste options. From the clipboard panel, expand the paste button to see all paste-aligned options. Step 42. Choose Align to selected levels. Select Align to selected levels. Step 43. Choose the first floor. In the dialog, select first floor and click OK. The tanks are now duplicated on the first floor. End of exercise. This completes the exercise for Module 8. You've now placed freestanding equipment, hosted fixtures, ceiling-based terminals, and multi-story components, all essential skills for real-world M.E.P modeling. Please don't forget to like and subscribe. I'll see you on Module 9.